victims that we are currently working to remove from the building.
4, 3, 2, 1.
Challenger now heading down range. 2 minutes 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles.
The explosion lit the night sky with a red glow and sent a cloud of smoke into the air. The Titan II missile that was inside the underground silo was armed with a nuclear warhead.
All too often, tragedies like these take place around the world, challenging our resources to avert disaster. If we could somehow identify the early signals of these events, we might be able to prevent them. Impossible? Well, there may be a way. Here at the Department of Energy's Sandia National Laboratories, researchers are on the cutting edge of an amazing new technology that can dramatically change our lives. Imagine a working machine with gears no bigger than a grain of pollen, so small that it's imperceptible to the human eye. Imagine microscopic smart machines that are mass-produced like integrated circuits, hundreds or thousands at a time for a few pennies each. Imagine a microscopic world where gravity and inertia are no longer important, where the effects of atomic forces and surface science are dominant. A world where gears and optical shutters can turn 10 times faster than today. Welcome to the new world of microsystems, where a dust mite looks like Godzilla taking a spin in a merry-go-round, and an aphid can get its legs stuck on a microscopic spring without damaging it. And the serious work of nuclear surety, non-proliferation, and counter-terrorist activities gain a new arsenal of intelligent devices. Just as the integrated circuit has changed the way we live and work over the last 30 years, microsystems are the dawn of a new age in scientific achievement with vast defense and commercial applications. The Silicon Revolution began over 3 decades ago with the introduction of the first integrated circuits. Since then, the IC has enhanced every aspect of our lives. They are mass-produced, small, light, reliable, low-cost, and they're everywhere. From wristwatches to medical instruments, to automobiles, to space vehicles. Over the past 30 years, the number of transistors placed onto a single silicon chip has risen from a few hundred to more than 7 million. The more transistors on a chip, the more processing power, the more functions the IC can perform. This growth in function, however, has been limited to the processing power of the chip. The next leap in function involves much more than simply packing more transistors onto the silicon. Very soon, a new generation of microchips will be capable of knowing where they are and what's going on around them. Microsystems that will not only be able to think, but to sense, act, and communicate as well. Imagine new sensors so small, smart, and inexpensive that they can be used anywhere, for any purpose. Imagine hundreds of sensors with amazing sensitivity and precision on a single chip. Imagine new, intelligent machines that could change medicine, transportation, chemistry, energy production, virtually any industry or scientific discipline, as profoundly as the integrated circuit has revolutionized the way we live. Sandia, responsible for the surety of the nuclear stockpile, develops microsystems as part of the mission of the Department of Energy's Office of Defense program to continue to enhance the safety and security of nuclear weapons. Experts at Sandia believe that these integrated microsystems will enable better detection of terrorist threats and greater control over conventional and nuclear weapons. A maturing microsystems technology will also reduce the costs of building and maintaining the nation's nuclear deterrent. Imagine making the locks on weapons so small that they could never be defeated.
I have a high degree of confidence in the science-based stockpile stewardship management program. I am very impressed with the scientific and engineering expertise that we have in this process. We know we have to improve those over the next several years in order to meet the objectives of the stockpile stewardship program, but I think we are on the right track.
Microsystems, a critical part of this program, also have the potential for creating an entirely new, sustainable global industry. The commercial applications are limited only by our imagination. The estimated market for intelligent micro machines is about $14 billion per year, and $100 billion per year for micro machine-based systems. Sandia has been involved in the growth of the IC industry since the beginning. The laminar airflow clean room, invented at Sandia over 40 years ago, provided the air filtration needed for the microelectronics industry to grow and flourish. Researchers at Sandia's laboratories for integrated microsystems have refined unique manufacturing methods to integrate mechanical systems and the control and communication electronics on a single chip. The Department of Energy is advancing this exciting new field by educating the public regarding this undertaking, by the education of new scientists and engineers in this field, and by continuing research and development of microtechnologies.
So, how many micro machines can run on the head of a pin? It's a question researchers will soon be able to answer as they slave over a hot microscope, trying to forge a tiny revolution with some far-reaching implications.
Right now, micro machines are already finding their way into a number of different applications. In most new cars, there's several. There's pressure sensors that measure the manifold pressure on the engine. And there's also the sensor that deploys the airbag as a micro machine device.
The facilities of the Microelectronics Development Laboratory, the Compound Semiconductor Research Laboratory, and the Integrated Materials Research Laboratory are unmatched anywhere else in the world. Sandia's scientists, engineers, and technicians are poised to realize this vision of intelligent, integrated microsystems and lead the United States in developing this exciting new technology. The vision is already beginning to become a reality. Microtechnology for airbag deployment is now licensed to industry for safety improvement in millions of products. Tiny hydrogen sensors are aboard space vehicles to detect hydrogen leaks that could cause catastrophic failures. Fully functional microscopic locks have been demonstrated that will enhance the safety of our remaining nuclear stockpile. And under development is a chemistry lab on a chip for detecting explosives, chemicals, and biological agents used in terrorists' weapons. Future advances in this field will enhance our national security while opening up potentially unlimited scientific advances, quality of life, and economic opportunities for our nation.